Yes. Today we're going to work on graphing parametric equations. So we are already done with converting from parametric equations to rectangular XY value equations. This time we're going to work on setting some table of values first. Okay, so let's read in here what we're going to do. All right, Maggie, go ahead, please. Let's read number instruction for number 7.
For the following exercises, graph each set of parametric equations by making table values, include the orientation on the graph.
Thank you. Okay, let's start with this one in here. This is, well, either of these two will be fine, number 6 or number 7. So, let's start with this, okay? So, let's get the values of x and y given those t. So, basically, just putting our values there. You can use it by computing it or by graphing it, all right? Let's start with x of t in here first. Okay, so since x of t is equal to t, so that means at -3, what's your x? Here, -3, right? Here. And similarly in here, it's basically the same, right? -2, -1, 0, 1, 2, and 3. Okay. The next one now is how to get our y. So again, our y is what? T squared minus 1. So for example, what's in here? So this will be what? -3, you square it, and then minus 1. Which is, how much is that? 8. Very good. Okay, so that means this point in here for xy will be what? -3, 8. Okay, now we're gonna do the same for the rest of them. And let's see how it looks like, okay? You know what? We can do our graphing as well. And to put it out in there, what is that again? Big Y of t is equal to, what's that again? T squared minus 1. Are we good? Okay. And let's see what those values are for the following. What are those values again? T equals what? Oops. Y of A. And what's your x again, by the way? X of t is equal to what? T. Equal to t. Okay. So what are the other values in here for the following? Okay, going back, where is it? Okay, here it is. So for -2, what's that gonna be, guys? -2 squared plus 1, 3. Right, that's correct. Okay, let's choose a different color for that, colored purple. Right, so this is A. That is what is it in here? 3. Okay. What is this? -1 square it. That's 1. Minus 1. 0. -1. Okay. What about in here?
0.
At 1. 1 squared minus 1. So 0. So basically this one will be the same as this, 3. And this one will be the same as that, 8. Okay, now let's see how it looks like. Okay, so if it looks like in here, that's your x of t and y of t, and I'm gonna put in here the following: big X of t, oops, comma, big Y of t. Just to see how the graph looks like for that. And we're gonna put in here, your t is what? -3 to 3. Okay, so here it is. And looking into our, let me just remove this red and xt and yt. And as you may notice in there, that will be our graph for, what's that? Yt. Okay. Now, where are those points? So let's see where those points are at in here, okay? So what are those points again? Negative 3, 8. Where's that negative 3, 8? Negative 3, comma 8. Got it? Okay. What's the next point? Negative 2, 3. Thank you. Okay. Next point, negative 1, 0. Okay. What's the next point? 1, 0. Okay. Excuse me. Next is what? 2, 3. And last two. Oh no, last one. 3, 8. Okay. See guys what we did in here? And that will give you the direction of this graph. Okay, so what's the direction in here? Let's color it a different color. Let's say blue. Okay, so this is at what? T equals negative 3. Okay, going there in that direction. This on that direction, this is at t equals negative 2. Okay, on this direction, this is your t equals negative 1. Okay, this is at t is equal to 0, right? That direction. Okay, this direction is at t equals 1, and this direction. Oh wait, where's that 0? 0, negative 1. So basically, there's another point in there, right? That's t equals 0. This is t equals 1, right? This is t equals 2, and this is t equals 3. Okay. Now, going to review, let's review our method for converting this parametric into rectangular, just to see if we actually got the graph right. Okay. So that's your x of t equals t, yeah, and your y of t is equal to what again? T squared minus 1, right? What's the first step? Solve for t on both sides, okay? Solve for t. So that means this means what? T is equal to x, right? And in here, what do? Add 1 on both sides, okay? Hence, t squared is equal to what? Y plus 1. And what do? Square root both sides. So t is equal to what? Plus or minus square root of y plus 1. Okay. And then with that, step number 2 is to combine these two. Okay. So that's what we call our substitution method, right? Substitution method. Combining these two t's, and that means what? X is equal to what? Square root of y plus 1. And then we can solve for y already, okay? Solve for y. So what do? Square both sides, very good. X squared is equal to y plus 1. And then, last one, subtract 1 both sides, right? Now let's see. Is that correct in here, right? So if we can verify in here, what is that again? Okay. You know what? I'm just gonna remove 1. Okay, just put it in here at the bottom. Oops. Is it right that this is the graph y is equal to, what's that again? X squared. X squared minus 1. And yes, we are correct. Are we good? Right. Again, in here we don't need to convert its xy equation. But, you know, it's a good analysis that, yes, we hit all of those marks right. But again, do not forget to consider the direction as well, right? That's why this is called a parametric graph, because of the direction, not only the curvature, but the direction as well. Questions? Okay, so that's table of values for x and y. However, let's consider now some more in here. Like this, okay? So okay, let's consider in here 47, 48, 49 and see how we can work on this one, okay? Let's exit out. and solve one of those equations in here, what do you want us to work on? Let's try doing number 48. Okay, so it says in number 48, A is equal to 2 and B is equal to 1. Okay, so with that being said, then we can write it as follows in here. Xt is equal to what? Sine 2t. Okay. And your yt is equal to your b is 1. Okay, so that's sine t. Okay, bless you. Now let's see, how do we do the graph for such when a equals 2 and b equals 1? So let's go plug it in decimals as such. So your big X of t is equal to, once again, what's that? Sine parenthesis 2t.
Is it supposed to be cosine?
I think it's both sine. Is it both sine? It's both sine, okay. But yes, in some given, it might be both might be one is sine and one is cosine as well, okay? Anyway, so in this case, what is the domain for x? What do you think is the domain for x? This is your t. In this case, this is your t axis. This is your x axis, all right? So what's your domain for x? Negative 1 to 1. Get it? Okay, so in that case, your domain for x is equal to what? Negative 1 to 1. Okay. Now let's also consider y of t, right? So let me erase this one and put in y instead. Big Y of t is equal to what? Did we say? Sine t. Okay, and what do we notice in here? Still the same, the range is from negative 1 to 1 as well, okay? So in this case, this is still your t, but this in here is not x anymore, but y, okay? So let me just erase this one and change this to y instead. As you may notice on your y, that is from 1 to negative 1 to 1, okay? So that means in here, the range for y is the same, negative 1 to 1. Okay? Are we good, guys? Getting the domain and range? Okay. Look at your x. The bottom and top of your x is your domain, right? Look at your y. The bottom and top of your y is your range. Okay? But your x values, the horizontal values in here are not x's, but t's instead. Okay? Anyway, let's now graph it. Okay, what is that line again, or point? Big X of t, there we go, comma, big Y of t, close it, okay, and then change this one from where to where? Negative 1 to 1, and let's see how it looks like. That's how it looks like, right? But let's see. What if this becomes like, say, 0 to 2 pi? How does it look like? Are we good? Okay, so that's one complete rotation for that. And as you may notice from here, okay, going back in here, seeing these values for such. Okay, and let me just erase this one. And analyzing this parametric graph, okay? What is the domain for this parametric graph? What's the domain?
Negative 1 to 1.
Very good, negative 1 to 1, right? Let's make color it blue, right? Let's emote from negative 1 to 1. That's the domain, right? Okay, right? Okay. And what is the range for this one? Let me color it purple. The same, negative 1 to 1 as well. Get it? Okay. Now, the next one is, how is the motion in here? Where do we start? Where do we end? Okay, so let's see. So this is what I'm gonna do to make sure about that. I'm gonna copy this whole thing, xt, yt,
change these t's to a's instead. Okay, and I'm just gonna make a slider out of that. Okay, ready? Okay, click on the slider. Okay, let's try first at a equals 0. Where is that?
Origin.
At the origin, right? So at a equals 0, it's in there. At a equals 1, where will it go? Okay, right? So at 0, that means t equals 0. It's somewhere here. Let me color it this yellow. Okay, this is start. Okay, and then it went here, right? Okay. Yeah, this is at t equals 1. That is at t equals 0. Okay. Let's continue. At a equals what? 2. Where does it go? Okay. So this is this motion in here. That t equals 2. Right. And do the same for the rest. Okay. T equals 3.
Is it back to the origin?
No,
No.
not yet. But it's almost there, right? Yeah. T equals what? 3. Actually, back to the origin, it's at pi. Okay, 3.14. Okay. Anyway, at 4, where is it? It's way beyond the origin already, right? Okay, so somewhere here. That's t equals 4. T equals 5. Okay, where is that one? In here. And t equals 6 is somewhere here, and it will go back to the origin at what value?
0.
At 2 pi, right? Which is the one entire rotation, right? So that means from here to here, going back here, that's pi, 3.14. Going back here, 4, 5, 6, and then 2 pi, it's gonna go back to the origin. Okay? Guys, so that will be the movement of this parametric graph. So let's verify. At 6, it's gonna be there. Now at 2 pi, where is it gonna be? Back at the origin, because that's one complete rotation. And it's gonna go on and on and on and on. Let's see. Verify. Okay. Click in here. I'm gonna click on this slider A. Okay. Go. And then do it this way, right? I'm gonna click in here. Click one complete rotation. I'm just gonna make my speed like really slow by 0.2. Okay, and let's see how it looks like. Okay, you see the movement of the dot, guys? Okay, so that's how it is moving. Okay, and that direction of the arrowhead will tell us what it looks like. Okay. Questions? Now, going back in here and seeing some of the other works, right? For example, what if we do number 49, where A is 3 and B is 3? How is that gonna work on in here? So we're just gonna change the A and B as 3's, and let's see how it will change the spiral, all right? Or the parametric graphs, okay? Let's go back in here, and you see these 2, we're gonna change this to 3, okay? And you're gonna see this y, we're gonna change this to 3 as well. Okay. Are we good, guys? What happened? Okay. So as you may notice in there, it's already like a line in there that we have worked on. Okay. Questions, guys, with what we did with that. All right. Thank you.